Hi beautiful people, welcome back to my channel with an amazing video. It's me Aryan Kumar and today we are going to learn deep about ionization energy. Let's deep dive into it. What actually ionization energy is? Right. The electrostatic force of attraction between the nucleus and outermost shell, whereas the electron is extracted by ionization energy, is known as ionization potential or ionization energy. Right. If I describe it in simple words, amount of energy required to remove the valence shell electron of an isolated neutral or gaseous atom to the infinity number, we will discuss it right now, is called ionization energy. Now we discussed few things that are unknown to us, for example isolated, neutral, gaseous, and infinity, of course. Right. As you can see, here's an atom, and in between we are having nucleus. There is a strong force. The strong force is known as electrostatic force. If I describe electrostatic force, this force is used for holding up the electron and maintaining the strong force of attraction between nucleus and the electron at whatever shell it is. It can be the last shell as well, right? So that's how the strong force, electrostatic force, looks like. The force that is strong for taking the electron out of this is the force that is electrostatic force. The ionization energy will be applied here, as I told, where whenever we need to take out such electron from an atom, the ionization energy will be applied. If in simple words, in my own language I describe it, अगर हमें एक एटम से इलेक्ट्रॉन को छीन के बाहर निकालना होगा तो वहाँ पे हमारे पास इलेक्ट्रॉन एफिनिटी नहीं, आयोनाइजेशन एनर्जी इस्तेमाल होगी. इलेक्ट्रॉन एफिनिटी इसके टोटली अपोजिट होती है, वो हम कभी बाद में डिस्कस करेंगे, राइट? Okay, so that was the basic overview. After this, the second thing will happen is electron goes to infinity, right? This is the whole concept in our upcoming class first year, so I'll not deep dive into it. I'll just simply explain what infinity is. Infinity is a thing whereas we cannot count a specific amount of numbers, a specific amount of atoms, a specific amount of molecules. It can be anything that is countable, but in infinity, as an infinity word, we cannot count it, right? So that's how I describe the word infinity. Okay, let's look at the formula. The formula says formula of ionization potential or energy, majorly used in physics. F is equal to, F is force, right? K, as you guys know, K is constant. Q1 our charge 1, charge 2, and our radius, that is our nucleus. That's how I define our formula. Okay. You can solve such equations. For example, if there's a question asking you, um, if there's an radius and there are 10 electrons, if I take 3 out of them, what will be the electronic ionization energy that is applied? So simply you will apply such formulas and get your answer ready. Okay. Later on, focusing upon its examples. Okay, let's discuss what ionization energy is and what isolated, neutral, gaseous states stands out for. Okay, if I simply say isolated is a term used for a single thing, single person, single atom, single molecule. But the thing is, it cannot be in a pair, it cannot be more than two, it cannot be even two. It should be only one, okay, only one. So this is how we describe isolated. So you can simply relate the definition with it: amount of energy required to remove the valence shell electron of an single atom, single molecule, or single state. Right? It can be neutral as well. What neutral is? Even not negative, even not positive, it should remain a constant number. Okay. For example, 1, 2, 3, minus 1, minus 2, minus 3. The only number neutral here is 0. So here I take an example 0 as a neutral number. Right. As I told you, the atom should be isolated always, not even in a pair. So, as you guys know, the gaseous form is always broken into molecular pieces. They are not combined together, they are not stabilized, they are always in a shivering position, and they always vibrate, being a moderate gaseous state. You can take example of any gaseous state, anything. It can be hydrogen as well. For example, if I draw hydrogen here, right, so it simply floats in our air. Okay, so that's how I define this concept. And if I take solid in case here, so solid is a block of molecules combined together. That's what makes it in a shape, and that is how the solid looks like. Okay, here is an example by chemical equation. Okay, um, for example, there is an atom, any molecule, and later on converting it describes our chemical equation. Okay, whereas I will discuss the heat capacity in our upcoming part in the same video. Okay, so let's discuss heat capacity and how it actually works.